Hi students, today we will discuss a previous year advanced question, a very interesting question and a very difficult question too. Just coming to the question, f of x equals to limit n tends to infinity n power n into x plus n into x plus n by 2 and so on x plus n by n by n factorial into x square plus n square into x square plus n square by 4 and so on x square plus n square by n square whole power x by n. So clearly the given question is like exponential function and they mention that it is x greater than 0. So you can observe clearly wherever x greater than 0, clearly whatever it is f of x is always greater than 0. That is the first point to be noted because of this one is an exponential function, whole power x is there. So whenever x greater than 0, f of x greater than 0. That is the one important point. Next, now come into the question. So here come into the numerator, take n common in each and every term. So how many terms are there in the numerator? What are there in the brackets? Are n terms are there? You can take n common from the each and every term. Then the question will be f of x equals to like limit n tends to infinity of n power n into, if I take common n in each and every term, that will become n power n into like x by n plus 1 to 1 plus x by n into one by 2 plus x by n into and so on. One by n plus x by n from the numerator, and from the denominator also you can take n square common. So here n square common, already in the denominator we have n factored is there. So if I take n square common, n squares n terms are there. So if we take n square common, 1 plus x square by n square 1 by 4 x square by n square and so on 1 by n square x square by n square whole power x by n. Now clearly n power n, n power n, n square whole power n will get cancelled. Now just look at the question, f of x equals to limit n tends to infinity. So the numerator you can write as it is 1 plus x by n into half plus x by n and so on 1 by n plus x by n divided by, so here that is the term n factorial is there. N factorial we know that it is like 1 into 2 into 3 into and so on. So 1 multiply with the first term, with 2 you can multiply with the second term, like that up to n you can just multiply. So keep on multiplying that like that. This will be 1 plus x square by n square, no changes, and here it will be 1 by 2 plus, here with 2 we need to multiply, right? 2x square by n square and so on. Here 1 by n plus n x square by n square and whole power x by n. Now to bring that exponent to the base, take log on both sides, then it will be log of f of x equals to, that exponent will come to the base and x, there is no value which depends on limit. So limit n tends to infinity 1 by n. Now if I apply the logarithm, log of a by b is log a minus log b, and the summation will become, so multiplication will become summation, right? Sigma. So here like I equals to 1 to n log of 1 by I plus x by n, correct? Because of here it is 1 by 1, 1 by 2, 1 by n and so on like that, minus the second term is sigma here also I equals to 1 to n, same it is log of 1 by I plus here it is a multiple of 1 is 2 3 and so on like that, so I x square by n square L8. Correct. Now this is what log of f of x equals to x into limit n tends to infinity 1 by n into, now here I'll take I LCM here, so it will become 1 plus ix by n. Here also I can take I LCM. After that separate that I and cancelled from this log, because of if I take I LCM here, log of 1 by I we can write separate, here also log of 1 by I plus log of 1 by I minus log of 1 by I will get cancelled. So clearly it is sigma I equals to 1 to n. Here what will get log of 1 plus xi by n minus sigma I equals to 1 to n. Here log of 1 plus x square I square by n square. Right. So clearly log of f of x equals to x into, now when coming to this limit n tends to infinity 1 by n, see this sigma I equals to 1 to n log of 1 plus x I by n by 1 plus x square I square by n square. Correct. Now from this, now I can take it as I by n as y. So clearly this one log of f of x equals to x into this, what we can write integration of 0 to 1, because of I equal to 1 to n, right? Then it is log of 1 plus x y by 1 plus x square y square then now I can take xy equals to t, right? Now I can differentiate with respect to y on both sides. X into 1 equals to dt by dy. Okay, then dy equals to dt by x. And the boundaries, now coming to the boundaries, if you substitute x equal to 0, it will be 0, y equal to t equal to x you will get. The lower boundary will be 0 only and the upper boundary x. So it is log of f of x equals to x into integration of 0 to x log of 1 plus t by 1 plus t square into dt by x. So here x gets cancelled. With the remaining time you can apply the differentiate with respect to x on both sides. Here x and here with respect to t. Now right hand side we can apply the Leibniz rule. Here it is like f dash of x by f of x, and the right hand side it will become log of 1 plus x by 1 plus x square. The final question. Now if you observe this, can we write f dash of x equals to f of x into log of 1 plus x by 1 plus x square. So clearly for x greater than 0, f of x is greater than 0, and the log of 1 plus x by 1 plus x square when x is greater than 0. Just see here. Now if in case of log of 1 plus x by 1 plus x square is greater than 0, then I can say that 1 plus x by 1 plus x square is greater than 1, right? So in case of this, x clearly lies in between a fractional value, because of we want 1 plus x by 1 plus x square greater than 1, so that it is very clear that 1 plus x is greater when compared to 1 plus x square. So x is greater when compared to x square. Correct. So it will become equal to 0 also in case of x equal to 0. So it will become equal to 1, and this one like that. Now we can take x common, x square minus x less than 0. So x is not equal to 0. X belongs to closed interval of 0 to 1. So in case of x belongs to closed interval of 0 to 1, the f dash of x value always greater than 0, greater than or equal to 0. So it is increasing function. F dash of x is increasing function in x belongs to closed interval of 0 to 1. So which means what? Coming to the question, f dash of 2 is less than 0, because of what? F dash of x is increasing in the interval 0 to 1 only. So coming to the option C, f dash of 2 less than or equal to 0, a correct answer. Why? Because if you check this options clearly, for suppose f dash of 2 equal to f of 2 anyway positive, and log of 1 plus 2 by 1 plus 4. So it is what? F of 2 into log of 3 by 5, a fractional value clearly. So fractional value which gives a negative, right? So clearly what it indicates that f dash of 2 is less than 0. So option C is correct. Now coming to the question, f dash of x. Now in our options, now coming to the option D, f dash of 3 by f of 3 greater than or equal to f dash of 2 by f of 2. Now see this, f dash of 3 by f of 3 is equals to what? Log of 1 plus 3 by 1 plus 9. So that is log of 4 by 10. That is log of 2 by 5. And f dash of 2 by f of 2 equals to log of 1 plus 2 by 1 plus 4. So clearly it is log of 3 by 5. And compared to these two, so this one is what? 0.4 and this one is 0.6. So this one, clearly we know that log of 2 by 5 only less than log of 3 by 5, as we know that. Correct. But the given question is f dash of 3 by f of 3 is greater. So this one is also wrong. So when compared to that, coming to option B, what is that? F of 1 by 3 less than or equal to f of 2 by 3. Correct. Because of C, we know that f dash of x is increasing, f of x is increasing function in x belongs to closed 0 to 1, right? So first 1 by 3, 2 by 3. So clearly in increasing from 0 to 1, f of 1 by 3 less than or equal to f of 2 by 3. Correct. Next, coming to the option 1. See that option 1, straight away it is wrong. Because of what? F of 1 by x is greater than they mentioned. No, because of it is increasing, right? Though f of 1 is greater than f of 1 by x, as x value is greater than 0. So option A is also wrong. Thank you.